Greetings. My name is Chip Appel. I'll be your instructor this quarter for Soil Science 121. I'm looking forward to doing that. Since I'm going to be away for the first couple of days of the quarter, I'll return on Friday, but I'm going to be gone on Monday and Wednesday at an International Soil Science Conference in San Diego, where the Soil Science Society of America, the Canadian Soil Science Society, and the Mexican Soil Science Society are coming together as one, and that's never happened before. So that's where I'm going to be. Here's the stuff that I'm going to cover in the next 3 screencasts. The first one I'll cover why study soil, give you kind of a course overview. Then we'll have a quick short one on the perspectives that we use to understand soils. And then the last one will talk about soil profiles and how we determine soil age. Before we do that, though, I wanted to introduce myself. So in case you've never seen me before, you know what I look like. So there I am with my family. This is about 6 years ago. So I'm on the far left there, and then I have twin daughters. Maggie's on the left next to me, and then Beatrice, and then my lovely wife, Beth. Here's a more recent photo of the girls this Christmas, and now they're 10. And then here's a recent picture from January 1st of this year at Cayucas Pier, where my wife and I, along with 1,000 or a couple thousand others, did the polar bear dip, where you just run and jump into the water with all these other people as a way to bring in the new year in a celebratory fashion. So let's get into why study soils and why it's an important thing to do. And before we do that, though, I'll post a link to this video. This is a video that I put together, I don't know, maybe 10 years ago, using my family as the cast and getting an idea in kind of a funny way, I think, about why people should study soil and what a soil scientist does. So anyway, why should we study soil? So one reason is because soils are a repository for carbon. And as you know, CO2 and methane are major contributors to climate change and our atmospheric temperature warming. And so if we can find a way to increase the quantities of both of those gases being stored in the soil, that's going to mitigate climate change and slow the raising of our global temperatures and maybe stop it. So soil scientists are studying ways to do that all the time. You may have been driving or been camping or just been out in nature and seeing landscapes that look like this and soil profiles, right, that look like this. And you might think, how the heck did that happen? And so one of the things that we're going to do in this class is talk about that. You may have seen soils that look like this on a stream bank, and the same idea might run through your mind there. And of course, soils are responsible for the production of 95 or more % of all the food and fiber that is needed for the growth and sustaining of the world's population. And soils, right, are necessary, and understanding what properties of soils allow for that to happen is critical to our world. Soil is also a major repository for contamination, right? And so you probably did not know this, but the Red Bull headquarters in Santa Monica used to be a spent car battery reclamation facility, and car batteries have lots of lead in them. And so this site has really high levels of lead in them, and that's a problem because lead stays in soils for long periods of time. That is, it's not very mobile. And when consumed or inhaled as dust, it can cause a bunch of different problems: cardiovascular system damage, cancers, and then in particular for children, brain damage and decreased IQ scores. And if you look at this little diagram, you can see that soil science is related to a bunch of different disciplines, and I bet you can find your major in this wheel here or tangentially related to what you see here. And here's a picture of a project that I worked on a few years back in the northern area of Thailand, where we are working with some indigenous coffee farmers who are looking at ways to enhance and sustain the fertility of their soils there using some compost and composting of some of the waste associated with coffee production. And here's a picture of Maggie and Bia again, in front of the Eiffel Tower in Paris. And I'm showing you this picture because all these things that you see in this picture came from the soil. The elements that were required to make the Eiffel Tower, those trees in front of the Eiffel Tower, my daughters, their clothes, the cotton candy, all that, right, came from the soil. And if we look at the earth, right, we know that 3/4 of the earth is covered with water. And if we look at the earth's surface itself, right, there's about 510 million square kilometers of earth's surface, about 150 million square kilometers of land area, and 130 million square kilometers of that is soil. It's a pretty finite resource, and therefore it requires, very careful management, because we know that it is necessary for all the other processes that we described above. And if we relate it maybe to something that is, something that you're familiar with, the amount of soil that we have is equal to about 31 billion acres, which is equal to about 31 billion football fields. And if we look at all the things that soil does for us, right? Medium for plant growth, recycler of waste materials, habitat for organisms, engineering medium, right? All those things, right? Soil performs for us. And without it, right? Without soil, there's no life. And if we talk about what does a typical mineral soil look like, right? So if you take a handful of soil, and this is something that you're going to need to do for your first homework assignment, is collect a handful of soil, put it in the palm of your hand, and this is what it's going to break down is going to look like, on a volume basis. So about half of the volume is going to be pore space, which is not solid, and the other half will be some combination of materials that were broken down by rocks, and that's the mineral component. And the other is going to be, various plant residues or broken down plant residues or even living roots. All right, so this is what a typical mineral soil looks like, and this is the type of soil that we're mostly going to be focusing on and talking about in Soil Science 121 this quarter. So the next screencast is going to cover various definitions that we use to understand soils, as well as the four main perspectives. And I'm not going to get too much into specific surface area because it is such an important topic that I want to be there with you when we talk about it.